We now discuss the solution of a problem from the section Differential Equations. The problem is related to the solution of a given differential equation. This question has appeared in the joint entrance examination main held on 6th April 2023 in the first shift. The given question is, let y is equal to y of x be a solution of the differential equation x cos x in brackets dy plus in brackets xy sin x plus y cos x minus 1 dx is equal to 0, where 0 less than x less than pi by 2. If pi by 3 multiplied by y of pi by 3 is equal to root 3, then modulus of pi by 6 multiplied by y double prime at pi by 6 plus 2y prime into pi by 6 mod closed is equal to. So we are given a differential equation, and y is equal to y of x is a solution of this differential equation. It is further given pi by 3 multiplied by y at pi by 3 is equal to root 3. Then required to find the value of modulus of pi by 6 multiplied by y double prime at pi by 6 plus 2y prime at pi by 6. We now discuss the solution of the problem in detail. We have this differential equation where 0 less than x less than pi by 2. Now divide this differential equation throughout by x cos x. Then you will get dy by dx plus xy sin x plus y cos x minus 1 whole by x cos x is equal to 0. Right. And in this, the coefficient of y we have taken out. So we have written dy by dx plus x sin x plus cos x by x cos x multiplied whole by y is equal to 1 by x cos x. Right. We simplify dy by dx plus x sin x by x cos x, x cancels, sin x by cos x, tan x plus cos x by x cos x, cos x cancels, will get 1 by x. So thus you get dy by dx plus tan x plus 1 by x in brackets multiplied by y is equal to x cos x. Yeah, we have put it in a recognizable form, that is a linear differential equation. Right. And it is of the form, this is of the form, dy by dx plus p of x into y is equal to q of x. So in our case, p of x is tan x plus 1 by x, q of x is 1 by x cos x. Now what is this? It is a first order linear differential equation in y. To solve such differential equations, we find out its integrating factor. The integrating factor is equal to e power integral px dx, and then we write down the general solution as y into integrating factor is equal to integral q of x multiplied by integrating factor and integrate with respect to x plus c, where c is the constant of integration to be evaluated with the help of given condition. Right. We go back to our problem. So we find out integrating factor e power integral p of x. P of x is tan x plus 1 by x with respect to x. That will be equal to e power integral tan x is ln secant x plus integral 1 by x is ln x. Right. So e power ln secant x plus ln x is equal to e power ln of x secant x. Ln of a plus ln of b is equal to ln of ab. Right. And this is equal to e power ln of x secant x is x secant x because exponential and logarithm are reciprocal to each other. Agreed. Agreed. We got it. We got the integrating factor. Therefore, we will write down its general solution. General solution is y into integrating factor. That is x secant x is equal to integral of q of x. Q of x is 1 by x cos x multiplied by integrating factor, that is x secant x, integrate with respect to x plus c. Now see, in this integral, cos x secant x, they get cancelled. The secant x, 1 by cos x is secant x into secant x is secant square x, and xx cancel. Yes, xx cancels. So it will be integral of secant square x dx plus c. Integral of secant square x dx is tan x plus c. So y multiplied by x secant x is equal to tan x plus c, where c is the constant of integration, is the general solution of the differential equation. So y is a function of x. Therefore, instead of y, we have written y of x into x secant x is equal to tan x plus c. Agreed. To evaluate this c, we use the condition. The condition given is pi by 3 multiplied by y at pi by 3 is equal to root 3. So put pi by 3, x is equal to pi by 3 in the above general solution. Then you will get y of pi by 3 multiplied by x means pi by 3 secant pi by 3 is equal to tan pi by 3 plus c. Agreed. Agreed. So y at pi by 3 multiplied by y at pi by 3 is root 3. So this part is root 3. So that will be root 3 into secant pi by 3 is 2 is equal to tan pi by 3 is root 3 plus c. So this is c is equal to root 3. Thus we have evaluated the arbitrary constant. So substitute back the value of c in the general solution. You will get a solution called particular solution. So the particular solution is y of x into x secant x is equal to tan x plus root 3. Yes. We continue in the next slide for further discussion. Right. This is what we have to require to find. And we have seen in the last slide y of x multiplied by x secant x is equal to tan x plus root 3. So we multiply throughout by cos x. Then you will get x into y of x. Y of x multiplied by x we have written as x multiplied by y of x is equal to cos x secant x is 1 is equal to tan x into cos x is sin x plus root 3 multiplied by cos x. So you are multiplying by cos x. Right. Now the right hand side, you take the right hand side, multiply, divide and multiply by 2. So 2 times 1 by 2 sin x plus root 3 by 2 cos x. Agreed. Agreed. So this will be 1 by 2 sin x plus root 3 by 2 cos x is, you can write it as sin x plus a. So this is equal to x multiplied by y x is equal to, this is 2 sin of x plus pi by 3. Yes, this is very familiar for us. Very familiar. So now differentiate. Differentiate once. Why are you differentiating? We want this y double prime, y prime and so on and so forth. So differentiate. If you differentiate first x into y prime x plus y of x and differential of x is 1. So this is only y of x is equal to differential of sin is cos 2 cos x plus pi by 3. Now further differentiate it once again. You will get x y double prime x. So y prime x into derivative of x is 1 y prime x only plus the derivative of y of x is y prime x is equal to minus derivative of cos is minus 2 sin x plus pi by 3. Agreed. So this is x y double prime x plus 2 times y prime x is equal to minus 2 sin of x plus pi by 3. Now look at what is required. The required is pi by 6 mod of pi by 6 y double prime pi by 6 plus 2 y prime pi by 6 mod close. So in this put x is equal to pi by 6. So put x is equal to pi by 6. Then you will get pi by 6 multiplied by y double prime at pi by 6 plus 2y prime at pi by 6 is equal to minus 2 sine of x. Pi by x is pi by 6 plus pi by 3. Pi by 6 plus pi by 3 is pi by 2. Sine of pi by 2 is 1. So the answer is minus 2, but we want modulus. So take the modulus. So if you take the modulus, it will be mod of minus 2 sine pi by 2. So mod of sine pi by 2 is 1. This is modulus of minus 2. It is plus 2. The mod is given only to get rid of that minus. Agreed. So the answer to this question is a numerical type question. The answer is 2. It is a routine question. What is asked in differential equations? But the thing is writing at this stage 2 times sine of x plus pi by 3 is a turning point. If you don't write this one, then the differentiations will get several other terms also, and at the end the evaluation may become difficult. But here, see, writing this multiplying by 2 and dividing by 2 and writing this as sine of this function, sine of this one x plus pi by 3, that is the turning point, and if you do that, that becomes easy. That is the detailed discussion of the solution of the problem from the section differential equations, and the problem is related to the solution of a given differential equation. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.